Now we will move on with tables and graphs for one variable. And while creating the tables and graphs, we will be covering the portions: opening a data file, exploring the data, creating histogram, frequency distributions, how to create bar chart for this distributions, and finally we will see how a session output can be print. So we will start with opening a data file. We have already saved a data set. Now we will move the cursor to the file, and you can select data from open, and you can choose the destination, and you can select the file, and you can click open, and as you can see, the data will be appearing on the spreadsheet in front of your screen. And if you move the cursor through the variables, you can see the labels of each variable is appearing. So this is how that you can open a data set. And now we will move on with exploring the data. So in order to explore the data, you can move your cursor to analyze, and in analyze you can see there is descriptive statistics, and in descriptive statistics there is an explore option, and you can click on explore. Your dialog box will be appearing, and in the dialog box there is the variables given, and you can select one of the variables and drop it to the dependent list. The factor list is optional, it is not mandatory. It is used only if you want to make any further explanations. So in our example, we are only sticking with dependence list, and you can click OK. And you can see on the output screen there is a case summary, a descriptive statistics, a stem and leaf plot, and a box plot will be available. If you look into the case processing summary, you can see that the number of observations is given, and the missing values and the total values are given in the summary. And in descriptive statistics, the standard deviation, variance, mean, standard error, etc. are given on the descriptive statistics table. And if you move downwards, you can see a stem and leaf plot given. And before moving on to the details, I will give you a brief explanation of the stem and leaf plot. The stem and leaf plot is used to represent a data. It is similar to that of a frequency distribution. In a frequency distribution, you can identify the number of observations falling in a class interval, but you cannot identify the exact value of those observations by merely looking into the table. On the other hand, in a stem and leaf plot, you can identify the number of observations as well as the exact value of those observations by looking into the table. Now let's see how it is possible. The stem and leaf plot splits an observed value into two parts known as stem and leaf. For example, if the observed value is 10, it will split into 1 and 0. 1 will become the stem and 0 will be the leaf. Stem values are represented in tens, hundreds, thousands, etc. and this is known as the stem width. Leaf values will be in units, tens, hundreds, etc. depending upon the stem width. Each leaf value represents individual cases or observations. If you add this stem width with the leaf value, you will get the exact value of each observation. Now we will move on to an example. For example, if you have 12, 13, 15 and 17 as observed values, let's see how it will be represented in a stem and leaf plot. As you can see it in the table, you can see how the figures are split into stem and leaf. All the four figures here fall in tens, so the stem width becomes 10, and that makes the figure 1 coming under the column stem equal to 10. As our stem width is in tens, each leaf value is in units. You can see there are 4 leaf values, that means there are 4 observations. Now if you add the stem width to each leaf value, you will get the exact value of the 4 observation, that is 12, 13, 15 and 17. So by simply looking into a stem and leaf plot, you can identify the number of observations and the exact value of those observations. Now we will move on to the example in our SPSS. You can see in the stem and leaf plot there is a frequency distribution given, and on the right side there is a stem and leaf, and the definitions of the stem and leaf are given at the bottom. The stem width is given as 10. That means the values falling in the stem column are in tens. So that makes 2 equals 20, 3 equals 30 and 4 equals 40. Now the leaf is said to be individual cases. So each leaf values to the right of the stem value represents individual observations. Now if you observe the first row, you can see a frequency. The frequency is given as 2. If you move on to the stem part of that first row, you can see it is given as 2, that means 20, and if you add it with the leaf figure, you will be getting 29. And there are 2 9s given on the leaf part. That means in our data set there are 2 observations possessing 29. So we can check it with the table. There are 2 values, 2 observations with 29. And if you move downwards, you can see there are 4 observations on the second row, and if you want to identify the exact values of those 4 observations, you can just add the stem value with the leaf value. So now if you add 3 with 0, you will be getting 30. And you can see there is only 1 0 on the leaf part. That means only 1 observation in our table possesses 30. That you can check it with the table. There is no other 30 here on this table. And if you move further to the right, you can see there is 2, and if you add 3 with 2, you will be getting 32. And as we don't have any other 2's in the leaf part, it means there is only 1 observation with 2, and you can check it in the table. There is only 1 observation with 2. There is no other observations with 2. And if you move further, you can see there are 2 4's. If you add the 4 with 3, you will be getting 34, and the 2 4's represents that there are 2 observations with value 34, and you can check it in the table. There are 2 values having the value 34, and likewise you can identify the exact values of each observations from the stem and leaf plot. Now we will move on with creating a histogram. To create a histogram, you can move your cursor to graphs on the menu bar and you can select chart builder, and the chart builder dialog box will appear in front of you, which we are already familiar with. And from the gallery you can select histogram and you can drag the simple histogram to the preview area. And now you can select the practice time and you can drag it to the x-axis, and the number of the frequency will be automatically appearing on the y-axis, so you don't have to drag anything on the y-axis. You can click OK and the histogram will appear in front of you. You can see the time intervals are given on the x-axis and the frequency of those time intervals are given on the y-axis. Here the shape of this histogram is chosen automatically by the SPSS. For your convenience, you can click on the graph and there is a chart editor appearing in front of you, and you can click on the bar. There is a properties dialog box, and in that property dialog box there is an option custom the x-axis, and there is number of intervals given. And if you change this number of interval, you can change the shape of the histogram as per your convenience. So now you can see the effect on the histogram. You can apply any number, you can give any number, and you can see the change on the histogram. And likewise you can change the number of intervals depending upon your convenience. Now in order to identify the highest frequency, the time interval with highest frequency, you can change the property to cumulative chart. You can see that in the element properties there is a statistic option, and when you choose you can see there is cumulative count, and if you click cumulative count and you can click apply, you can see the change in the histogram, and the resulting figure will be giving a cumulative frequency graph will be appearing in front of you, and the height of this each bar represents the number of observations falling between a particular time interval. So that is how you create a cumulative frequency graph. And now we will move on with creating a frequency distribution. Move your cursor to analyze, and in analyze you can see descriptive statistics. From descriptive statistics you can select frequencies, and in frequencies you can see a dialog box will appear and you can select a variable. I am selecting sex of the swimmer, and you can drop it to the variables box and you can click OK. And when you click OK on your output screen, a frequency table will appear, a frequency distribution will appear showing the number of males, females, the percentage, the cumulative percentage, and the total figures will appear in that frequency table. So that's how you create a frequency distribution. And now we will see how to create a bar chart for this frequency distribution. You can simply move your cursor to chart builder, and you can see the chart builder is where you have left. You have to change the statistic to back to histogram, and you can click apply. And now you can select the variable sex of the swimmer and drag it to the histogram here. Sorry, it is not the histogram. We are to select a bar chart. So you can drag the bar chart to the preview area, and you can change the statistics. Once again, you have to change it to histogram and click apply, and you can move the sex of the swimmer to the x-axis. And now you can click OK, and you can see the graph bar chart in front of you, and you have to check whether the data represented in the graph is same as represented in the frequency distribution. In the frequency distribution, it is given that the number of male and female is equal, and in the graph also you can see that the number of male and female is equal. So now we will move on with printing the session output. Now we have completed a session, so we will see how to print this session output. To print this session output, you can click anywhere on the output screen. Remember, you must not click on any particular output. You have to click on an open space in the output screen, and you can select file and you can click print, and you can see the print range is all visible output. Okay, now you can click OK, and you can get the print of your entire output session. And if you want to choose any particular output, you can just click it on the outline area. Now I have selected the sex of the swimmer, and it is highlighted in the outline area. And if you go to print, you can see the change here. The print range is now changed to selected output. So if you click OK, you will be getting the print of your selected output. So this is how you print the session output, and that's all for today, and we will continue with the rest of the portions in the upcoming videos. Thank you.